Welcome to the class. In this section 10.6, we are going to be working on ordinary annuities. Annuities provides a way of people to accumulate some funds that can be used later on for retirement or to pay a debt. Basically, a person opens an account with an institution that offers annuities, and they every so often make a deposit, whether monthly, quarterly, or yearly, or whenever they have an opportunity to save money. This money is going to accumulate, and then there will be a time when you know that you need to try to use this money, and then you can start to withdraw on a monthly basis. And so for people who are in retirement, it could be an additional income that could supplement whatever they get from Social Security, or if they have a pension plan, or if they have a 401k in their savings accounts, or whatever vehicles that they use in order to save for the future. So we're going to get into this issue of annuities. In order to understand them, I have a couple of examples to show you, and then try to do your homework to practice how these calculations work. There is an example where we are going to use a table. This is just for an example, because every institution that offers annuities, it will be attached to a specific interest rate. So therefore, the amount of money that you put in, the term that you have this annuity for, a number of years, will increase the amount that you will be accumulating. And of course, the interest rate is in compound interest. So let's delve into it now. This is the homework for section 10.6, pages 624 to 625 on ordinary annuities. So we need to look at what annuities represents. The definition here says an annuity is an account into which or out of which a sequence of scheduled payments is made. The amount of money, another definition here, the amount of money that is present in an ordinary annuity after T number of years is known as the accumulated amount, or the future value of an annuity. And basically what that is telling us is that as we open an account for an annuity, if we divide the number of periods that we are going to contribute, we're going to start probably very small, and then the interest that we earn from here, it will add it to whatever we put in again. So this number will go up a little bit, and so forth. The next time it will go a little bit more, and then a little bit more, and so on. So this basically will continue to grow, and it'll depend on, of course, it will depend on interest, on the interest rate that once basically does all this accumulation of assets over a period of time. So the curve that you will end up at the end of the period, let's say that you contribute for X number of year, it most likely will be something like this, right? It will grow. The interest that you will be accumulating will be compound interest, and then there is a point where there is a cutoff here, right? When you basically stop contributing, and then you start to withdraw from it, but you don't withdraw all of it. So you start to withdraw little by little. So basically, this curve will eventually go down depending on how much you withdraw, right? That's basically the idea here. This is the way the curve will go up as you accumulate, and that will be the value where you stop contributing, and then you start to take money away from the account. Now, the annuities, in general, you can put it in money market, just basic interest, or you can put it in a stock. Every person decides, where to invest the money, and giving on the amount of risk that one wants to take. In the book, we have some examples, and as an explanation, they show you page 619, table 10.6 on ordinary annuity growth, right? So this is how we're going to grow. As I said earlier in the drawing, right? Let's say here you start with $100, and the next time you add another $100, and then another $100, and so on. You continue to do this until the point here that you continue to add $100. And the example that they have in the table, they said that this is going to be for 360 months to do here. So now you have the first number of payment, $100, but there is nothing contributed to it. The first time that you made the deposit, basically the $100 goes straight into your account. The next paying period, which is you have the first number of payment, $100, but there is nothing contributed to it. The first time that you made the deposit, basically the $100 goes straight into your account. The next paying period, which is number 2, you contribute another $100, but then it earns this interest because they're giving you 5%, right? This table is calculated as a 5% compound interest rate, and then you add that to the previous $100, so basically you end up with $200.42. The third payment, another $100, you add another 84 cents as interest, and then to the previous $200.42, and you ended up with $301.25. And you continue to do this over a long period of time, and then you get to the period point of 359, and then you accumulate by that time $82,780.94. And then when you complete this at the 360 months, after that you accumulate $83,225.86. And this is we're going to continue now using the formula for ordinary annuity. We have our amount, the principal. We have this bracket here, 1 plus R over N raised to the NT. R is the rate, N is the number of payments made. The T is in years, minus 1. And this has to do with the fact that the first installment that is made does not receive any interest, because it's the beginning of the counting sequence for the whole annuity period. Then you have the rate divided by the number of payments. The definition right here. Remember, the interest rate is always given in decimal form, so make sure that you keep track of that, and this is the way to do it. n divided by 100. Make sure that you know that really well. The time in years, be careful, because sometimes it's given the payments could be quarterly, semi-annually, or annually, but make sure that you know that is in years. There is an example here that is not in the book. Basically, I use the example that we had in the table. P is equal to 100, the time is in 30 years, the rate is 5%, we get the decimal point. Now, when calculating the amount, you put the principal, the quantity in the brackets, 1 plus 0.05 divided by 12, that's the decimal of the rate right here, divided by 0.05 divided by 12. And this calculation, when you use your calculator, if you're able to capture as many decimal points as possible, the more accurate your calculation is going to be. If not, it's going to differ from the calculation that we did in the table. Now, the -1, this is an important thing here to take into account. Again, this is the first payment that is made, but no interest is added to the account at that moment, right? So this is at the time when you do the first installment payment. So if you do the calculation, you plug it in and you do all the arithmetic, you get to the point where you multiply the numbers. Again, if your decimal points are larger, you get more accurate numbers, but they're here. And in the end, you end up with 100 times 3.4677 and so on, depending on the digit that you use, divided by 0.004166, and then you can add more digits there. And this division here results in $83,238.118 as a decimal. We need to convert this into cents, so it makes sense to make this into 83,238.12 cents. If we remember what we did with the table, right, there is a difference here of a few dollars, and they have to do again with the truncations of the periods. Okay, so let's move on. Now let's do example 1. In example 1 in the book, page 620, a family is depositing $250 every quarter. The interest rate is equal to 4%. It's 4 over 100. You get 0.04. And the time is in years, 35 years that they're going to do this. And you have your formula here. Right? That's the formula. You plug in the numbers, 250. You put the things in the bracket here. 1 plus 0.04 divided by 4. Because it's quarterly. Quarterly means that basically you're paying every quarter, right, in a year, right? So it's 1 quarter here raised to 4 times 35, right? And so you plug in the numbers, you basically end up with 250 multiplied by, open the brackets, 1.01 raised to the 140 minus 1 divided by 0.01. If you continue with the calculation, you end up with 250 and then multiply by 4.022709 minus 1. You divide this by 0.01. You continue with the calculation, you get 250 times 3.027099 divided by 0.01. And that results into 756.77475 divided by 0.01, and that results into this number, 75,377.475, and then we round off this number to 75,377.48 cents, and that will be your answer in the book. Now, remember the idea of annuities. have to do with accumulating money over a period of time. So basically, let's go back to our sketch here, more or less, what we have. Basically, we have this point where we are accumulating, right? We are accumulating assets or funds, whatever you want to call them, right? You're making contributions over a period of time, and then you growth your amount, but then eventually you start to withdraw, right? So here you were putting money in, right? And here basically you're taking money out, right? And the idea of the annuity is that you are going to have enough time toward the end of life here, right? So you don't want to end up living for, let's say, 10 more years, and then the money runs out here, right? That's the idea that we are trying to avoid. We want to extend this money as long as possible. And this is basically what annuities can do for you. The company that provide these kind of services will tell you that you project when you can start to take the money. One important thing to know about annuities is that it's, for example, you have a life expectancy of 100 years, right? So the question is, when do you want to start to withdraw the money? Do you start at 70? Do you start at 60? Or when do you want to start? The idea again is for this money to last until a person, last day of life. So one idea that one can contemplate when working with this is one to have to consider one's lifespan, right? We contribute money for a number of years, right? We continue money. Then let's say at one point we stop, right? We stop. Do we start taking money at that point, or you let the money sit there and grow a little bit more, to earn more interest, and then at a particular time, then you start to get the money in. The idea is for this money to last for a long time. Okay. Now, if for whatever reason, let's say the person doesn't live to their expectancy of whatever years that is, and the person goes before that time when it's calculated to last, that means that there will be some residual left, right? We don't know how much is going to be left, and that money basically is in the account, and it can go to the family. A person is designated to be the beneficiary of this account. So that's another benefit that these annuities have. Also, if for whatever reason there are emergencies that come along, some people are allowed to take some amount of money from time to time from that same account, but that means that the calculation has to be done again to come up with the money that will be distributed monthly. But originally the idea is for the money to last there for a long time and not to be taken unless there is an emergency, and that is also taken into account for these annuities. Thank you very much.